Hello class, in this video I'll be showing you how counting principles can be used to determine the probability of an event occurring. Let's begin. In a common form of the card game poker, a hand of 5 cards is to be dealt to each player from a deck of 52 cards. What is the probability that a person is dealt all hearts? This is called a heart flush. Alright, so I've already gone ahead and labeled this as a combination, and that's because each arrangement of the 5 cards is the same hand. Order is not important, and that implies that the arrangement AB is equal to the arrangement BA. And now that we know that, we can determine the probability. So I'm going to label E the event dealt 5 hearts. And then I'm going to let S be the event dealt 5 cards. So the probability of E is going to be the number of outcomes in the event dealt 5 hearts divided by the number of outcomes in the event dealt 5 cards. So I'm going to start with the denominator. This is going to equal 52 choose 5. And that's because there are 52 cards in the deck, so this is the total number of cards. And 5 is the total number to be selected. And now for the numerator. The number of elements in the event, or the number of outcomes in the event dealt 5 hearts is the following. 12 choose 5, and that's because there are 12 hearts in the deck, so this is the total number of hearts. And the 5 is the total number of hearts selected. So that has to occur. We have to take 12 hearts and select 5. What also has to occur is the fact that there are 39 remaining cards and we want to select none of them. Okay, so here I'll write this out. This is the total number of remaining cards. Total 0 is the total number selected. All right, so the probability that a person is dealt 5 hearts is equal to 12 choose 5 times 39 choose 0 divided by 52 choose 5. And this is approximately 0.000495. So there is a very, very, very tiny probability you will be dealt all 5 hearts. All right. How about we figure out the probability that you get a flush of any suit? All right, so in a deck of cards, you can get a heart flush or a club flush or a diamond flush or, let me just move this over here, a spade flush. Each of these probabilities is going to be identical, and we figured it out in the previous part, 0.000495. So this is 0.000495 plus 0.000495, and so forth, and so forth. So this is equal to 0.00198. Still a very small probability that you are dealt a flush of any kind. All right. What is the probability that you were dealt a full house of 2s and 8s? All right, so in this scenario, we have to select 2 aces out of 4, and we have to select 3 8s out of 4, and we have to select 0 cards from the remaining 44. All right, so here I'm going to let E be the event dealt 2 aces and 3 8s. And I'm going to let S be the event dealt 5 cards. So the probability that the person is dealt 2 aces and 3 8s is equal to the number of outcomes in the event E divided by the number of outcomes in event S. So we already know the number of outcomes in event S. We did it in the first part. That is going to be 52 choose 5. Now we just need to figure out what goes on in the numerator. So to select 2 aces out of 4, that is C of 4, 2, or 4 choose 2. To select 3 8s out of 4, this is going to be 4 choose 3. And to select 0 cards from the remaining 44, that is going to be 44 choose 0. So the probability that the person is dealt 2 aces and 3 8s is the following. It is 4 choose 2 times 4 choose 3 times 4 choose 0. So this probability is approximately 0.000000923. And we are done.